Okay. So here we are again in live transmission. So we will start now the second session of the Romanian Conference on Energy Performance of Buildings event, organized today together with the Technical University for Civil Engineering from Bucharest, with the Romanian Association of Building Services Engineers, the Romanian Chamber of Energy Auditors, and the Energy Policy Group. I will be your moderator for the next session, together with my colleague and friend, Florin Baltorețu. Florin Baltorețu is associate professor at the same university as myself. He is the vice rector for scientific research and international relations. He was the vice dean of the Building Services Engineering faculty and also former head of Department of Thermal Sciences in the Technical University of Civil Engineering. So welcome, Florin. We will do together this job to facilitate the USERT session in our conference. And I welcome also our international guests. First of all, I invite Jarek Kurnitsky to present the NZEB developments and challenges in EU. Mr. Kurnitsky is the chair of RIVA Technology and Research Committee, professor at Tallinn University of Technology in Estonia. Is also professor at Aalto University in Finland. He is currently leading RIVA COVID-19 task force, preparing European HVAC and ventilation guidance for an epidemic situation. He is the leader of Estonian Center of Excellence in Research, NZEB, Zero Energy and Resource Efficient Smart Buildings and Districts. He is internationally known for the preparation of technical definitions for nearly zero energy buildings through many activities in RIVA Technology and Research Committee and contributions to European standards. He has been deeply involved in the work to improve the energy efficiency and indoor climate of the built environment in Estonia and Finland, with major contribution in the development of energy calculation frames for present energy performance regulations. So, a way of speech, you are one of the fathers of the EPB regulation and legislation in Europe, Jarek. Welcome again, and we are honored to have you to our conference and to listen to your nice and very interesting presentation. You have the...
Thank you, Katalin. So I am sharing now my slides. Thanks for the introduction. And yes, I will try to do some sort of overview what developments have been happening in nearly zero energy buildings, what are challenges, and very specific focus to renovation. That is one of the main issues currently. So there has been more than 15 years of systematic work with energy performance of buildings, and this really started with first Energy Performance of Buildings Directive 2002. Now this has been 2 times revised, so recasted. 2010 brought nearly zero energy building requirement indeed after 2019-2020 to be applied, but when it was put to the directive, when also very important cost optimality principle to set national requirements and energy use to be measured in primary energy. When latest changes have been long-term renovation strategies and also smart readiness digitalization of the buildings, what has been seen very important. And at the same time, everybody knows these 2020 targets, and now we already have fixed 2030 targets, and Green Deal will even go to much longer until the carbon neutrality 2050. So these apply very much for the buildings, but there are also for the products, all the HVAC products covered, what are specific requirements in the eco-design directive, so minimum requirements for energy related products, and then also a labeling system, similar like energy performance certificates in the buildings, all these labels for the products. So that's the frame. And currently 2030 targets have been fixed with very ambitious 55% greenhouse gas reduction and also very ambitious energy efficiency target, 32.5%. So this energy efficiency target is quite complicated how it is measured. This is done from 2005 projection without energy saving measures. And from this curve, one needs to reduce by 20% by 2020. So this is basically already done. And then by 32.5% by 2030. Last year's developments have not been so good in energy efficiency. So energy use has been slightly above the target. Both measured in primary energy and final energy, these curves are reporting. So there is about 4.8% performance gap when we speak about the primary energy. And this means that more effort is needed by the member state to reach this 2030 target. So this has been the most complicated target out of these three. At the same time, CO2 reduction and renewable energy targets have been met, but energy efficiency has been more difficult. So what are more specifically main drivers for improved energy performance and also improved IAQ, so indoor environmental quality in the buildings? We can list two things in these directives. First, setting this nearly zero energy buildings target, what has been now implemented in all member states from 2019 and 2020. So for public and for all new buildings. Then another thing, what is even more important, is the cost optimality principle, what was also set 2010 first time. And these cost optimality calculations have been conducted already twice. And it is this cost optimality calculation actually developed the content for national nearly zero, national NZEB definitions, because it was said so that the NZEB should be at least on cost optimal level. Indeed can be more ambitious, but when for the cost optimality calculation, it is required that these have to be conducted with 5 years interval, and this means that minimum energy performance requirements in every country may change after every 5 years. So I will come back to this cost optimality in more detail, what is the definition and so on. I take this historical picture. This is 10 years ago when was recasted and NZEB was set in the directive, and when all countries basically developed some sort of a roadmaps how to approach the nearly zero what was when required for roughly for 2020. So this really initiated big development in Europe. And this development, the content for that was very much provided by these cost optimality calculations. And cost optimal energy performance is defined so that this is a performance level that will lead to the lowest possible life cycle cost when one will sum construction cost plus all this energy operation cost, maintenance cost, so on. And the calculation period for this life cycle calculation, what is basically a typical investment calculation, is set for 20 years for non-residential and 30 years in residential buildings. So it is called as a global cost, and there is a methodology well defined as a regulation and also available as a European guideline to do this and European standards. So this is a very well set methodology, and 2 rounds of these cost optimality calculations have been conducted in every country. And when it is defined so that national requirement can have maximum 15% deviation from this cost optimal energy performance level calculated with such life cycle calculation. So this really has changed Europe, and now we can see also the performance development as 2 rounds of calculations have been conducted. In this table, you can see it's about 20% in some building categories, bit more, in some categories, bit less. What are European average improvement figures within 5 years based on these 2 cost optimal calculations? And the figure below is an example from Estonia, where the improvement is even more, actually 2 energy performance classes in the certificate in new buildings and by 1 class in existing buildings. So this is quite impressive development what has happened. When it is not so easy to compare these national nearly zero energy building requirements and to get some basic understanding if in some country these are very strict or not so strict. And for that purpose, European Commission has published already 2016 recommendations for all climatic zones. So there are 4 climatic zones in Europe. And in every zone for office type of buildings and residential buildings, so primary energy values are available, so that this net primary energy means that on-site renewable energy, also exported one, is reduced. So for instance, this 20 will be achieved when the 80 without on-site resources, and the rest will be just reduced when you get this 20 and 30. It's a simple, simply to subtract from this primary energy use when on-site generation is not taken into account. So basically this net primary energy is something what is recommended for all member states, and according to the climate zone, everybody can pick the correct value and then to compare what is the situation in national requirements. This is one example. So these are, yes, North Europe, where I am coming, these countries. So these European recommendation 40 to 65, and then we see in Denmark the area is included, in Estonia it's 105, and so on. So values, real values in national regulation are very, very different. And then it is also what energy uses are included in these primary energy values. That's also a big question, because basically this EU recommendation is set for heating, ventilation, air conditioning only. So it means that electricity use for appliances and in residential buildings also electricity use for lighting is not taken into account, and that would explain why these values are so small. So in many countries still more energy uses are accounted. For instance, this Estonian value is explained just by the appliances and lighting, what is taken into account also in residential buildings. So it really brings up a question how one could compare these requirements, and that's some sort of a challenge. European Commission has collected data already quite many times. This report is from 2018, and here you can see that the lowest value, 20, is from Denmark, and Romania, 93 to 117. But these might be old values because data collected from 2018, and highest value, maximum value 170. So basically you can find everything in between 20 and 170. So evidently content of these values is different and direct comparison would not be possible. This is more latest data from October last year. This is the latest what is available on European level. And when European Commission has actually Joint Research Center has tried to somehow to normalize these values, what have been reported by member states. But I would say that this is not very accurate. Actually, in the case of Romania for office buildings, seems to be very low values, so seems to be very high energy performance requirements. But in many countries, the values are much higher. And once again, we have a range from 20 to 180 even. And there is also included that European Commission recommendation as a blue bar, and when these new buildings indeed in many countries have more strict requirement compared to existing building, which might have another value, but not in all countries. So that's a European challenge, how to manage these NZEB values and how to be capable for inter-member state comparison. So first step in this comparison is so that the same energy uses will be accounted. So if this heating, ventilation, air conditioning only is taken into use, then you can see, for instance, Estonian value 105 will decrease to 46. So that's really a major step to compare similar energy uses. And the further step would be indeed to take into account national primary energy factors, which are all different, and then to use European average primary energy factors to recalculate this value. But indeed, calculation methodologies also can make a big difference. And this is one example where NZEB values have been compared in a couple of countries. So Denmark here belonged to Oceanic climate zone, and Estonia, Finland to Nordic climate zone. And when this comparison showed with national calculation methodology in Denmark, requirement met, but when it was not possible to meet Oceanic European Commission recommendation, because this was somehow very strict. Even an Estonian building move to the Denmark did not meet this requirement. However, in the Nordic zone, Estonian building exactly met the European Commission requirement. So this shows the technical challenge, how difficult it is. And for this type, more accurate comparison, reference building needs to be defined. And when it needs to be defined so that it will comply either with national requirements and when can be compared to the European Commission requirement, or to be defined so that the complies with European Commission requirement and then vice versa to compare with national requirements, and to change the input data and calculation methodology accordingly. So really a rocket science. When coming to existing buildings, and here the main issue are just these long-term renovation strategies, which are required by 2050. So with the aim that all existing buildings in Europe need to be transformed to nearly zero energy buildings within next 30 years. And it is estimated that the renovation rates must be roughly tripled to achieve these, as generally 1% renovation rate is the case in the most countries, and it is estimated that 3% every year needs to be renovated of existing building stock to achieve these targets. And these national strategies need to introduce milestones for 2030, how much renovated, how much done at that performance level, for same for 2040 and finally 2050. Strategies should not cover only, let's say, these renovation volumes and technical issues, but also how this renovation will be supported and financed. So this funding is indeed very important. And currently, 13 of these are already available and have been analyzed by European Commission. So in this report, these first analysis of first 13 long-term renovation strategies in Europe is available and has been done. So this is really a process what is right now ongoing with very fast speed. And finally, in the directive, there is very important point regarding to indoor air quality, ventilation, thermal comfort, so that it is said that IAQ should be set so that health, indoor air quality and comfort levels are really optimized for good health. And that's very clear mandate to member states to establish minimum requirements also for ventilation and other IAQ requirements. And that's very important both in new buildings and in especially in major renovations. So to be able to implement this directive, and I think here how good ventilation would be achieved in renovated residential buildings, it will need a lot of work in Europe, and that's a crucial question. When coming to the statistics, what's the current renovation in Europe? So, and basically, according to statistics, 75% of existing building stock is not energy efficient, and means that 75% of existing building stock in Europe needs to be deeply renovated to nearly zero within next 30 years. And annual renovation rate has been about 1%, and it is estimated it needs roughly to be tripled. And what is the renovation in Europe currently? So renovation indeed is conducted quite well. So there is one period reported average values. So a lot of renovation is done, but is not related to the deep renovation. These percentages are almost zero. So also in the Romania, a total percentage, how much renovated, very nice value. But when you go to the deep renovation, what is required by these long-term renovation strategies, it's almost zero. And that's really a challenge, how to move a renovation effort just to improve a building so that also energy performance and indoor climate would be improved. And basically this deep or medium level would be required by these strategies and current percentages, and also Romanian figures very similar to European average figures. These are very low, so that's a real challenge. Then it is a question how to do it technically. And I will use my last slides to give an example where old buildings from Germany, Estonia, and Italy are taken as a reference cases, and when deep renovation concepts applied for these. Actually, these buildings are quite similar. When you take old apartment buildings from Europe, in every country, quite similar buildings. And in this analysis, 3 renovation concepts were applied. I will describe these in the figures. It's easier to tell. So first renovation concept is very common in North Europe. So it basically will arrange mechanical exhaust ventilation and will collect heat from exhaust air, so that heat exchanger is installed and exhaust air heat pump in the basement. And when this heat generated by exhaust air heat pump is used for the space heating and also for the domestic hot water heating. And it is the best recommended solution for the intake air is a ventilation radiator, which are commercial products, so having filters and preheating intake air. So this will then work in very nice fashion so that nobody will not comply about the draft, and ventilation is really assured in every living room and bedroom, and then yes, mechanical exhaust ventilation and heat recovery from the exhaust air. At the same time, indeed, building fabric is renovated when it becomes a deep renovation concept. So all the facade, windows, roof to be insulated, so on. And the second concept is very similar, still based on the exhaust air heat pump, but then with cooling functions, so that the fan coil units would be used instead of these radiators to provide at the same time heating and cooling capability. And the third concept studied, and the last one, is centralized mechanical supply and exhaust ventilation with heat recovery implemented so that air handling unit installed on the top of the roof, and then all this ductwork installed to the facade. So sometimes old stacks can be used for the exhaust. Sometimes they are more easy to be installed on the facade in the insulation layer, and supply air ductwork always installed to the facade and will be in the insulation layer. So that's a common insulation thickness, about 200 millimeters, what has been applied in North Europe. So when it is easy to install also ventilation ductwork on the facade. And there are some photos how it looks. So indeed, the main point is that this ductwork installation and insulation needs to be done at the same time. So it needs to be deep renovation. Otherwise, it will not work if somebody would think that first let's insulate the building, and then after that it would not be possible to install ventilation ductwork in the facade if that is already insulated. And these concepts provide very nice savings. So you can see that the starting points, independently of these climate zones countries are representing. Indeed, it's in Italy is a bit smaller, but in Germany and Estonia, very similar starting point. So the savings are quite significant. And in Estonian case, with third concept, so with this ductwork insulation on the facade and centralized supply and exhaust ventilation with heat recovery, provided the best result when calculated with national methodology. And it was really funny that German methodology calculated exactly the same value. So you cannot see any climate effect, but there are issues in national calculation methodologies, but these are not capable calculate all of these renovation solutions correctly. And in Italy, you see perhaps more logical results. And it was really confusing when it was checked which energy performance certificate classes were achieved. So in Estonia, we achieved class C, what is required for a major renovation, and this was a class B. But in Germany, this one was class B, and these ones were class A+. And that's because in Germany, delivered energy, not primary energy, was used in the certificate. And then indeed, it's very, very favorable for the heat pumps. So it does not distinguish district heat or any other heat source from the electricity. Will be summed at the same fashion in Estonia, calculated with primary energy factors, so results completely different. So there is a lot of difference in these national methodologies. And that was the reason when all these concepts were simulated with the values taken from the European standards and the calculation methodology basically defined by the European standards, and then more reliable results was possible to calculate. So you can see that, for example, this third concept, centralized ventilation in Estonia 73, and now in Germany it is a lower value 61. So results are much more logical. In Italy, you can see that the cooling starts to be significant. When you add cooling, then you will have higher values. So basically, that's a kind of a challenge to be capable for correct energy prediction already when we speak about apartment buildings. When you will go to office buildings, so on, more complicated technical systems would easily generate much more challenges. And in this case, yes, but what was visible, it is interesting when in Estonia with these heat recovery ventilation, you will get the best result. So it represents the situation in a cold climate. But in these warmer climate zones like Central Europe or when going to the South Europe, when exhaust air heat pump provides the best possible result. So technical solutions, the same technical solutions provide different performance depending on the climate. So the optimal solutions really depend on the climate. And that's very promising result for the exhaust air heat pumps, which are almost not used in Central Europe. But these could be really very effective solution in these climates. So especially in these warmer climates, Germany, Italy, exhaust air pump provided very good results. And in a cold climate, when we centralized heat recovery ventilation was the most effective. So to conclude my presentation, basically this development has resulted in quite ambitious requirements of nearly zero energy buildings. Indeed, we can believe that mostly these are very ambitious in all countries. However, it's very, very complicated to make any comparison. And that's indeed thanks for this directive and nearly zero energy building requirement once set in the directive already 2010, now implemented everywhere. But yes, these requirements show numerically very broad range and cannot be easily compared. So this harmonization of the energy calculation would be very nice, or at least to conduct some, let's say, adequate comparison so that the same energy uses will be included and the same primary energy factors to be applied. That would be very important first step. And to solve this type, let's call this NZEB confusion, European Commission has launched official recommendations, so every country can conduct a comparison to these values available in 4 climate zones. And it has been also stressed that NZEB ambition level should be at least set to cost optimal level, and this cost optimal methodology is very well developed and supported with a good guidance. And it really has been a major driver for the energy performance improvements in practice in Europe. So revised EPBD, now it needs NZEB renovation for almost of all existing building stock, or let's say roughly to 75% of existing building stock to be renovated. And also a strong focus to the smart features and monitoring have been included, and that's indeed important to be able to monitor the performance. And finally, what will define energy performance improvement is a real performance of HVAC systems, what was well shown by these calculation examples of the renovation concepts done with national methodologies, and when compared what's the real result if European standards and the European methodology would be applied. So actual performance of HVAC systems, it's likely very important in the near future to be achieved, and when we would be capable to achieve these long-term targets as well. Thank you very much.
Thank you, Jarek. Okay, I see now that we are all together. It was a very consistent presentation. What can I say? Thank you once again for giving us such important details and presenting the results of your scientific work, not in your country, but throughout Europe. So it's a quite referencing or how to say, very high level of presentation. However, I have, let's say, several questions. We don't have too much time, and thank you because you framed your presentation exactly in the given period, 40 minutes, maybe less than that. You mentioned at the beginning of your presentation that we have to base our financial calculation on the cost optimal global cost concept. And I saw there is a difference between the payback period for public buildings, 20 years, you said, and 30 years for residential buildings. Why this difference between these two building categories?
Yeah, this 20 and 30 years have been defined since from the beginning when this methodology was launched, but it is likely, it is assumed that in commercial buildings, let's say, all the tenants will change and improvements are made more with a shorter interval. So that's the reason that in commercial buildings and public buildings, so non-residential buildings, it's expected that HVAC systems will be anyhow upgraded with shorter time period. And that's 20 years is, it is quite often the case in the reality. When the new tenants will come to the building when quite big, let's say, renovation works can be a case, and indeed when it is also justified that replacement of a systems is seen as a shorter time period. And residential buildings indeed are more stable, and when you need to expect that if something is installed, it should work for next 30 years. And one cannot expect that these buildings will be so often renovated. This also shows how important is this deep renovation concept thinking, because if you once make something, then you need to wait for the 20 or 30 years to make a new improvement. So all the renovation not well done will lock these buildings for the energy performance improvements. That's really a crucial question.
Mm-hmm. Thank you. I liked very much the solutions you presented for residential buildings. In order to implement also the ventilation systems in these buildings. We don't have too much, again, I have to admit this, but maybe it's time to say that we had started a special task force proposed by one of our RIVA colleagues from Poland, Tomasz, and in the next 1-2 years, we will have a RIVA guidebook presenting the most important solutions for residential buildings in Europe. Can you say a few words, because I know that you are very involved, and it's important also for our audience to know that RIVA is not only producing, I don't know, very scientific material, but also very practical, and all engineers could approach RIVA guidebooks.
Yes. These RIVA guidebooks are intended especially for HVAC professionals, and these are practical guidebooks, or let's say majority of these, and these renovation concepts will be prepared so that these are really easy to apply in practice. And indeed, nationally, it is important that some financial support as a renovation grants or something is supporting this type of deep renovation. Otherwise, you cannot expect that market will do so many renovation solutions and in so deep fashion at the same time. That's very important. But basically, it is required in these long-term renovation strategies that the funding should be organized and finance should be available for the renovation.
Okay. Florin, do you have questions for Jarek or?
Hello, thank you very much. Yes, I do. Hello, and thank you once again for your kind presentation and your kind participation to this conference. My question is related to the problem you raised about cost optimality. And in fact, about cost optimality calculation in different parts of Europe, because I suppose that this type of indicator will change from country to country due to different types of from the cost of materials and workforce to specific taxes and other economic problems. How do you think that this could be at least filtered to have a uniform methodology or calculation to compare in some proper way the same building could have different cost optimality depending of the country in Europe. So how, or if we have some procedure to specify a category of cost optimality as a function of the country or of the region?
This is true, but still the calculation methodology is exactly the same. And what is different is national input data.
Exactly.
It is true that construction cost, material cost, interest rates, energy prices, these are all national data. But the calculation period is fixed, and then you can select, is it investment cost type of a calculation, or is it another is, let's say, when you operate also with a carbon price, but there are two options how to do. But it is built so that every country can use and has to use national input data. And indeed, when result will apply in local conditions. And indeed, these national requirements, minimum requirements are set for the local condition. So let's say, I would say it is even not so important what are absolute differences in between countries, but inside your country, you can see how this cost optimal performance level will differ from the regulation and will lead to the development what when needs to be put to the regulation, so that minimum requirements will be upgraded based on these cost optimality calculations. And when, yes, European Commission has had some attempt to follow how this has done and developed in Europe, and there are some results reporting with about 20% improvement in average in Europe, but country-specific values indeed show much more variation. It's a challenging topic, but this is the only procedure what is very well set by the regulation, and the methodology is well defined. So in this way, it's a great tool.
Yeah, this is clear. Thank you. Thank you. No, I just think if some kind of normalization for each country could provide some indicator that could be eventually compared between countries, among countries. Okay. Thank you very much. Thank you.
Okay, thank you, Jarek. We have to hurry a little bit. We have 10 minutes delay. Is not a problem for the time being. I hope we will stay in this 10 minutes delay. We have another big expert present today in our conference, Mr. Jaap Hogeling. He is manager international affairs of ISSO. Then he is a member of many national advisory and normalization committees in the field of building physics, energy in buildings, and the building services system. He's responsible for the development of the Dutch procedures for the EPBD energy certification. He is a member of many CEN committees, for example, CEN TC 371 since April 2003. He is currently responsible for the second mandate 480 to CEN regarding the EPBD. So you can see the importance of Mr. Jaap Hogeling, and we are very proud to have him today. I won't continue the presentation because I want to leave the floor to listen to you and to inform us about the preoccupations at EU level. So, Mr. Hogeling, floor is yours.
Thank you. I have, okay, I can see, I have to share my screen, or?
Yes, you.
Oh, I didn't know that. Okay, I will.
We can wait. In the meanwhile, we have your nice picture.
Yeah, then I have to open my PowerPoint. Yes, okay.
Then I can say that you are also involved in many European projects. You are one of the leading specialist expert of the EPB Center, and of course you also are one of the most important promoters of this important institution. You are also a fellow of ASHRE. You are member of the ASHRE Research Administration Committee, ASHRE Technology Council, and you are also the editor-in-chief of the Riva Journal.
Thank you, Katalin. I think
now, so I filled the time. Now we can see your presentation, and please go ahead.
Thank you very much for inviting me for this presentation, and all your kind words. Also, I want to thank the previous presenter, Jarek Podnetsky, for his great overview and a very informative presentation. I'm also speaking about the renovation wave and the impact of the EPB revision on the implementation of the set of EPB standards. And this is my background. You already know it, so I don't have to repeat it. When I speak about the set of EPD standards, I always want to show this slide, and it is reflecting the fact that the 52 standards we developed under Mandate 480, they describe how you have, on basis of your input data on climate conditions, your indoor environment and building properties, can calculate the energy need, and based on the standards on the different systems, cooling, ventilation, heating, domestic hot water and lighting, and building automation, you can calculate the energy use, which finally is expressed at the energy performance certificates. What about the Green Deal and the renovation wave? There's already in previous presentation given a lot of details on this. The essence is that buildings are acknowledged as one of the key focus areas of the European Green Deal, and more specific for the renovation wave strategy. As you have heard before presentations, finance is becoming more and more available and will reach out in the coming decades to needed scale to transform the building for reaching by 2050 a healthy, safe, efficient, and sustainable decarbonized building stock. This is the target we see in front of us. The renovation wave was adopted in October 2020. The ambition is, as said before, at least double the annual renovation of the EU building stock with a focus on deep renovation. And so not anymore the low-hanging fruits, it has to be deep renovation. This is also a basis for urgent revision of the EPBD. We know the version of 2018, but the Commission decided that we have to revise the EPBD to direct the national renovation strategies to achieve the decarbonized building stock by 2050. Three focus areas in the renovation waves can be looked at: tackling the energy poverty and the worst performing buildings as a first step, and transform them also to decarbonized and healthy housing and buildings. And also a priority for the public building renovation as a lead example for the market to show what technologies and what priorities can be taken in the deep renovation process. Public buildings could be schools, could be universities, could be hospitals and office buildings. So it's up to the local governments to take action in that region, and they can do that easily because they are the boss. And decarbonization of the energy delivered to and exported from buildings is also a focus area in the renovation wave. To accomplish this, the Commission promotes MAPs, minimum energy performance standards. I find this a confusing term because we use the word standard in another context. I think it's better to say minimum energy performance requirements. Of course, the requirements have to be assessed on a standardized way based on the EPB standards. But it's a fact that the Commission is using these words. The use of energy performance certificate and the use of digital building logbooks and building renovation passports. How is the process of EPBD revision at this moment? The target is to be ready by 2021, the end of this year. There are various consultation mechanisms used, public consultation, public stakeholders workshops, questionnaires. There's currently a questionnaire on the Commission website available, which closes June 22. Some observations based on the workshops held so far. On the question on the vision of the participants on the decarbonization of the building stock, it was clear that a large majority of the participants welcomed an EU harmonized greenhouse gas matrix, which is great, as the current EPB includes just an encouragement to member states to report on the greenhouse gas emission at the energy performance certificate. Some countries do it, but not all. And also the way it is calculated is not harmonized. And it is very welcome to see that the majority of those people who are consulted, they say, well, this should be harmonized. Otherwise, we don't have a level playing field in Europe. And that is something that also Jarek mentioned, that this is it makes it difficult to compare the results in different countries. In this context, I want you to refer to the newly published standard 17423, energy performance of buildings, determination and reporting of primary energy factors and CO2 emission coefficients, general principles. This standard was published last year, and the target group of these standards are the users of the ZEB standards, and especially the national standardization experts and the building authorities who are in charge of defining the primary energy factors and CO2 emission coefficients that are the basis of the energy performance declarations on the certificate, and also the basis for the report to the Commission. This standard provides a transparent framework for reporting on the choices related to the procedure to determine primary energy factors and CO2 emission coefficients for energy delivered to and exported from building as described in the overarching standard 52000. The standard specifies the choices to be made to calculate the primary energy factors and the CO2 coefficients related to the different energy carriers. You may remember that in the overarching standard 52000 in the Annex B, we give tables with values for this. These tables are based on what I call expert opinion. Now, with this standard, we give an assessment procedures for these values and also the choice of the different assumptions for assessing these values. The standard is primarily intended for supporting and completing the overarching standard, as this standard requires values for PEFs and CO2 emission factors to complete the EPB calculation for the energy certificate. The content, I will not go in detail, but this is the content, and I show it because it shows the philosophy of all the EPBD standards. We give a general description of the methods and the choices, the basic principles to assessment methods. We give a short description of choices that you have to make to do the calculations, and set different choices related to the primary energy factors and CO2 emission coefficients. And we also explain choices to be made related to the parameter of the building, the object where the energy is used, and the geographical parameters, and choices related to the calculation conventions and related to the data, to the assessment methodology. So it means that we don't prescribe those choices. It's up to the member states and the policy and the policymakers in the countries to make these choices, but the standards gives them the possibility to report it in a transparent way, so it is possible to compare the different primary energy factors and CO2 emission factors between different countries. Another question on the revision of EPBD was, well, what are the possible instruments to be prioritized to reach this 55 reduction target in 2030 and later? And if you see how the participants on the workshop reacted, it is clear that they prioritize the MAPs, the minimum energy performance requirements, as I say, for the existing building stock. A phased introduction of EP requirements where the long-term renovation strategy should be clear. EPCs and building renovation passports could play a role in this process, and that is reflected by also the outcome of this workshop. And another question was, how can we make the energy performance certificate more popular? This is also an issue of the USERT program, where we want to make the energy performance certificate more user-centered, because in many countries, these certificates are considered as, let's say, administrative burden when you want to sell or rent out your building, and it's just a piece of paper. But that should change, and people should really understand the importance of this document. Why there is some mistrust in the document? Well, there is a performance gap. We know that the calculated value is not what you see on your energy meter, if you have one. And there is not real on-site verifications in all countries. So we have to address this. And also, it was said that we should add an indoor environmental performance indicator to the energy performance certificate. RIVA published earlier a position paper on this, where we also plead to include this in the energy certificate. And when you think about an indoor environmental indicator, you can look at the EPBD standards on the indoor environmental data, the 16798-1, or the tail indicator, as was developed in the Eldon project. In the RIVA journal, we published about these before. And there was also a clear statement to also connect to it a building renovation passport or digital building logbooks, which are accessible for the building owner and user. So they can see in this passport or a logbook like you can do with perhaps your car if you have a proper service manual. What is the status of your building and which measures should be cost-effective to take and you can follow also the history of the building in the coming years. Addressing this performance gap seems a very important issue. we all know why it is there. The asset rating is based on the standard user pattern and standard outdoor climate, and not a prediction of the real energy use of the building. And that message is difficult to communicate. It is not real because generally, even if you compare it with the measured values, you have a problem that the measured values also include non-EPB uses. Well, how to correct for that is also complex. This is difficult to communicate, and EPCs based on the calculation are just there to compare buildings. Well, people are not understanding that well. So we have to make the energy certificates more user-centered. And the user program will support this with tools and communication. The calculation procedure, especially when based on monthly calculation steps, includes a lot of assumptions, which may not be valid for all cases. And that is also a reason why this gap is there. The step to hourly calculations, especially in the case of deep renovation and nearly zero energy buildings, will improve the outcome. And for this, we also published at our EPB Center website a short movie you can look at. This is the link. So we think that in the revision of EPD, reducing this gap will be important. Apart that an hourly procedure is more easy to use, more transparent, reproducible, and in innovation supportive, it is expected that it will also reduce the performance gap as such. This wish to reduce the gap and to make the EPC more attractive for the general public could lead to more EU-wide support for development of an open software kernel based on the set of EPD standards. As this software is based on the set of EPD standard and is fully traceable and transparent, which is needed when you want to use this in the context of building regulation. So I plea for a need for an open common software kernel, and I've seen that Riva did something similar to support an hourly approach. This greatly facilitates the uptake of a practical application of the set of standards and avoids that the same work has to be done again and again in the different countries, because currently we have more than 30 national and regional assessment procedures in the market. And that it takes a lot of maintenance and a lot of work in every country, especially when you have monthly procedures. You have to have a lot of debates about the assumptions you find acceptable in your country, given the building traditions and the way buildings are used locally. Further, making a suite of high quality educational material, making a link to the software use freely available online will remove the last major threshold for practical application of this software kernel. What will be the impact on the use of EPD standards? A more stringent policy regarding the EPCs, their quality and the acceptance will emphasize the role of correct use of the EPD standards. An EU harmonized greenhouse gas metric will make use of the standard I mentioned before, and reducing the performance gap by improving the reliability of the calculated asset rating will require an hourly calculation step, which brings also the use of a smart readiness indicator to a next stage where the building and the grid interaction will become visible and able to demonstrate the level of decarbonization of a building used by the decarbonization of the energy used by the building systems. If you want really to show in the calculation how smart control of building systems and the interaction with it works out in the performance, you need at least an hourly calculation step. Several countries, you could say, have already an hourly possibility, often for non-residential buildings like France and Spain. Several countries are working on it, like Italy and Croatia. Several countries discussed to change over, but not now yet. I spoke with DIN, where several German experts expect that this will be likely done in the next revision round. And many countries express, yes, we want to do it, but please make a core we can use, because otherwise we all have to repeat the same job again. An example is already published in 2019 and by Laurent Segal on the Italian situation, and there he said time steps should be hourly standard required for legal purposes. When using hourly procedures, it can be traceable, and if you want to train, that is also possible. And I can just refer to the 52,016, which is the hourly energy need calculation. You can already run this program that is at our website of the EPD Center and see what is the difference between the energy need calculation in your monthly procedure compared to the hourly procedures. And this is freely available, so the study can be done. Well, I thank you very much for your attention, and if you are interested in more information on the set of EPD standards, we are there for questions. Look at our website or drop us an email. We'll try to answer your questions. Thank you very much.
Thank you, Jaap. Again, great presentation. A lot of information offered to our audience. I have a short comment and a short question, and taking into account that we have a slight delay, I would like to ask my colleague Florin to not mind. We will put just one question, my question, and we will go to the next speaker, because the other international speakers have also very interesting presentations. So thank you for presenting us this new SEM standard 17423 for the determination and reporting energy factors and CO2 emission coefficient. In fact, we had a vivid discussion last days about the most correct values which we have to take into account in our national methodology. We spent a lot of time to get the correct procedure, but now we see we have one, so we will follow it and implement it into our national methodology. But we have probably to spend additional time in order to have these factors calculated, because you can't calculate them, let's say, very fast and easily. My question, in fact, is linked to the comment, and I wonder if in the future, near or on long term, the energy consumption in buildings will be over charged. What we pay for the energy consumption will take into account probably the CO2 emission. We will apply this principle. The pollutant will pay more than the ecologic consumer. What do you think?
Yes, well, I think it is a logical development that in the future, the you could say the CO2 emission or the carbon footprint of the building, the building user has to pay for it. So for the energy bill, it can mean that if you use energy that is still having a big CO2 emission, then you pay a higher price, because at this moment the CO2 is not that expensive in Europe. It's around 50 euro, or just below 50 euro still. And they expect, if it becomes around 70 euro per ton, that all energy saving measures are already cost effective. But it is not calculated in the gas or the oil we buy at this moment. And when it is put on the price as let's say as a tax, then it will have an impact on the choice of your energy sources, and you will look out for more renewable energy source. And that is also the requirement, as Jarek explained in the EPBD, to have a certain margin in the renewable part of the energy you use. So that will offset, of course. But another next step will be that we also include the CO2 that is included in our products. And that will be a next step. But I don't want to make it more complex at this moment. But that will be the next step, that we also have to think about the solutions. If the solutions are not causing a lot of CO2 emission at a different place, because we buy and apply products that are not very environmental friendly produced. So that is also a discussion going on in Europe at the level of the Commission, to see if we can also attach the CO2 emission to the products.
Thank you for this very clear answer, Jaap. Thank you again for the presentation. And we stay in touch, because you are really a source of big information, and what to say, we are very proud that we have you as a friend, not only as a collaborator. So I will leave now Florin to lead this moderation forwards. So Florin, please.
Thank you very much.
Thank you.
It is now the time to present you Enrico Fabrizio from Politecnico di Torino. Enrico Fabrizio holds a PhD in Energy Technologies from Politecnico di Torino and INSA de Lyon, and is an associate professor of building physics and building services at the Department of Energy of Politecnico di Torino. He works on performance simulations and optimization of zero energy buildings and HVAC systems. His research is conducted through both numerical developments and experimental test sites to increase an energy conscious design of buildings in cities, as well as livestock structures and controlled environments for agriculture. He participated to different International Energy Agency EBC annexes, and since 2018 he is an associate editor at the Sustainable Cities and Society journal. In 2014 he was awarded the RIHWA Young Scientist Award by the European Federation of Air Conditioning Associations, and he is author of more than 90 peer-review indexed international papers. Now we have the honor to follow his presentation about simulation coupled to optimization for the design of zero energy buildings. Please, and welcome to our conference.
Thank you, Mr. Chair, for this very kind presentation and for the invitation. So you should see my presentation now, I suppose. It is a real pleasure for me to be here to talk with so many Romanian friends also. So let me start from the fact that what has been seen 10 years ago is a theoretical objective has become really a current construction standard, as also the previous presentation have indicated. But the zero energy building target has also been the driver of a large amount of research activities over the last at least 10 years in the field of building energy performance. And despite the differences that arise when we look at how zero energy buildings are defined in legislative requirements and standards, well, if we were asked which is the recipe of a residential zero energy building, for example, the answer we would give is, well, super insulation, mechanical ventilation, system efficiency, and the use of renewable energy sources. But the design of a ZEB is far from being as trivial as that. The current design of a ZEB will not necessarily be resilient in the future or will be able to adapt to climate change. So even though a considerable amount of research has been performed on the zero energy building target, there is still room for improvement in the optimization of such system. And the number of research activities around this topic are increasing constantly. Now, many studies on ZEBs are based on optimization. From the manual and trial errors approaches to refined computational method, algorithm, because there is always the need to find a solution that is stable in a scenario of conflicting requirements. These are also problems that are highly constrained. And the optimization functions are usually multi-objective, but recently also these studies are multi-domain studies. So not just thermal, but also visual, but also, for example, acoustic. So there is the need to approach this problem as of the design of ZEB as a whole. But let's look at how we may summarize the generic optimization problem of a zero energy building. We have to reduce an objective function subject to some constraints. The constraints are related to the performance parameter, to the decision parameters that regards the envelope, the system, the renewable energy, the energy sources. These constraints are the modeling assumption and the boundary conditions, but also the building energy model itself. So if this is a problem, how may we summarize the main feature of this problem? Well, we have a multi-dimensional optimization problem with a quite large number of design variables. We have to deal with discrete design variables. And one good option for solving method is the one which is called the simulation-based optimization method, which is a trade-off between complexity and accuracy. Frequently, algorithms that are called meta-heuristic are used, like genetic algorithm, like particles wall optimization algorithm. Why this? Because let's just take a very simple case study, a very simple example. This is just a single family building, 2 floors. Let's model it into a multi-zone simulation tool. Let's create this model into Transys. We would like to optimize it. We would like to increase the performance and work on some design parameters like the thermal resistance of the walls, like the types of windows or the shading length, etc. We are dealing with 9 variables, just 9 variables pertaining to the envelope. We have some minimum, maximum, and some steps of variation for each variable. Well, this very simple problem gives us a 9-dimensional, a non-uniform 9-dimensional search space, which is composed by this very large number of points. Each point represents a configuration of the building. And if we do this assumption on the solving, which are quite standard, well, the simulation time of the entire design space will be 130 years. This is clearly not feasible. So the solution is twofold. One may be to reduce the order of the problem, so to go to reduced order methods, and this is usually done when we are dealing with optimization coupled to operation. So operation and control. Into optimal control, usually detailed model are not used and reduced order models are preferred. Instead, the other way is to use some optimization algorithm. Now, I would like to present some examples of the potential that can be obtained by the use of simulation-based optimization method. Basically, each slide will be based on a single study. So for further information, please refer to the reference which is indicated in the slide. A first aspect I would like to focus on is the fact that it is really important, the exploration of the domain. So the exploration is as important, we may say, as the optimization. This on the left is the traditional, I would like to say, the classical diagram of EPBD, of cost optimal approach. So it reports the global cost following the EPBD directive and guideline as a function of the net primary energy use. We know very well this type of diagram. But if we look around the optimum neighborhood, in the neighborhood of the optimum, let's say plus 3%, plus 5% of the lowest global cost, what happens to the various design parameters? We can see an example on the right. Some parameters, some installation thickness, for example, are quite stable. The one on the bottom. Others are characterized by very high instability. So these report the frequency, the occurrence of the parameters in the neighbor of the optimal solution. So the design of a zero energy building should be presented in such a way that each design parameter can be characterized by an appropriate reliability indicator. Another important topic for zero energy building design is the study of the trade-off between building efficiency, system efficiency, and exploitation of renewable energy sources. Because we asked us which is the point at which I should stop the reduction of the energy demand and go to the supply of energy sources. Well, in this work, we studied how a solar cooling system, which is one of the few technologies that can be used to cover the cooling demand of residential buildings by renewable energy. And for that reason, it's very important. How solar cooling system may cover the energy demand and the domestic water heating demand of a multifamily building. As a function of the renewable energy ratio, as you can see in the graph, as a function of the global cost and of other energy performance indicators like the non-renewable energy consumption, etc. So these optimization studies are based on the variation of all the design parameters of the systems, like the volume of the storage and the technical characteristics of the storage, like the water flow rate in between the storages, source side and use side of the storage, and the panels, the number and characteristic of the panels, etc. All this is quite important to give some reference value for the renewable energy ratio of new residential building. As I told you before, also the multi-domain simulation are gaining attention. This is a study that addresses the nexus between sound insulation of the envelope and energy performance of the whole building that is also influenced by the envelope, obviously. So, for example, this graph reports the sound insulation index of the whole building. It was a weighted sum of the sound insulation index of facade, opaque and transparent facade for the various rooms of our case study building, as a function of the primary energy, but also as a function of the cost, trying to maximize both the requirement, the energy performance, the sound insulation, with a given value of global cost. And finally, I would like to present you an interesting application into a real context of simulation and optimization, which is the one of the Solar Decathlon China 2018. I think that most of you will be very familiar with what Solar Decathlon is. There are many Solar Decathlon around the world. I know that also the Bucharest teams won Solar Decathlon in the past years. So this is the experience of the SCAT, South China University of Technology and Polytechnic di Torino team that presented the long-plan prototype. Now, this is the prototype which is intended to be a sort of renovation building into an existing traditional Chinese context. This is the building built in Dezhou, which is the contest site. Dezhou is the solar city of China, we may call it. But the building, as you may know, was built first time in Guangzhou, which is where is the South China University of Technology. Then it was dismantled and then rebuilt again at the contest site. The contest took place for 2 weeks in summer, in a very hot and humid Chinese summer. So after the first construction in Guangzhou, we had the possibility to do some measurements, and the measurements we used also for calibrating the building energy model. You may imagine that within the process of the Solar Decathlon, we did a very massive use of building simulation for following all the design of this building. But once we had the real building built for the first time, we were able to find the models and to do calibration based on measurements, and thus obtaining a calibrated building energy model. Then we wanted to use it to increase the contest score. So we wanted to win. We want to increase the contest. So we asked ourselves, may we be able to express the contest score of the Solar Decathlon as a function of some performance parameters? So we set up an optimization process, starting from the calibrated building energy model, implementing all the contest schedules that were requested by the jury, defining the objective function, which was the maximization of the contest score, and simulating the design and the operation. Now, the objective function is based on the contest rules. The rules are 10. Some rules are based on assessment from juries. Well, these are non-quantitative, but all the contests, all the points that were measured by scores, by, for example, monitored variables, etc., we were able to express as an objective function. So this relates, for example, the penalty curves or the Solar Decathlon contest rules into the objective function. You can see, for example, that the temperature has to be within 22 and 25. Instead, you lost some points, and then you take any points at all if you are too far away from the optimal point. So this gives a sort of objective function, and the setup of the simulation-based optimization method is as such. So coupling the Transys models with the GenOpt optimizer, with the MATLAB tool for doing some post-processing and some analysis linked to both the Transys and the GenOpt tool. The simulation period was the one of the contest. So those 2 weeks of the contest, we decided to have a very refined time step of 1 minute in order to accurately simulate the performance of the HVAC systems, not just to have some information on the performance of the building. Now, what about the optimization variables? The fact is that we had the possibility of improving the design, small possibilities, okay, because it was between the first construction and the final construction in the contest site. So some parameters are design-related parameters, like the slope of the PV array, for example, which was able to be adjusted at the final test site, like the type of the shadings that we had not yet installed, like the some thickness of the insulation that may have been changed, and other important parameters, well, the operation-related ones, like the time of ventilation control times, like the control of the movable shadings, like the set points that influence the performance, and then in turn, set points influence also the points of the objective function. So finally, starting from a first attempt of 162 points of our contest objective function, we were able to maximize to 177, which is plus 8 and 9%. Which is more interesting is to know which are the optimal design strategy. So this final column. The most important finding was to reduce a bit the insulation, the thermal insulation, and increase the mass, the thermal mass. And then all the information on the operation, like to use for a larger time the shadings, and to use it at not at 100%, but at 50%, to turn on and off earlier the ventilation system, and to adjust and to lower the set point temperature from 24 to 21. Was just the set point. Then the actual temperature that was within the house was calculated by the tool as well. It occurred in the contest. So in the end, also this optimization process, the prototype won the competition. It won also the first prize into the engineering aspect. So the jury also was quite impressed by all the documentation on the energy performance study of the building. And now to conclude, I expect I was able to demonstrate and to give you some information on how simulation-based optimization methods are useful for assessing, for demonstrating the impact of technologies, and make really this building system integrated design possible. Simulation should not just be seen as a static process, but simulation goes with the life of a project, of the design, and of the building itself, up to what may be seen as a digital twin approach. And the fact that in the last 5 years, I would say, the simulation-based optimization approach had gaining more attention is also testified by the fact that the latest releases of commercial software tools have been integrating some parameters optimizers, some algorithms for doing some quite simple optimization. The research I presented was done by using some custom-made optimization process, but it is interesting to know that also commercial tools are moving towards this application. Thank you for your attention, and I also report some reference in the last slide. Thank you.
Thank you very much for your very nice presentation. I would like to have the opportunity, because you talk about solar decathlon, to say that in 2023, this event, this very important event, will be hosted by the Technical University of the Civil Engineering here in Bucharest. So we are welcoming you to come and to test your optimization results. I also had some questions, but your presentation was very clear, and you answer indirectly to my questions about the optimization module that you use. Only one that I want to discuss with you. Did you consider different influence of the parameters? Because not all the parameters have the same influence. Some parameters have a bigger, let's say, impact on the solution. So I think this could be a very good way for the future to use the results from the previous calculations and to use some weights that you can let's say, distribute through the variables in order to find more rapidly the gradients or for the interested variables.
Yes, that is a very interesting point, because, well, sometimes we develop before the optimization some sensitivity studies by applying, for example, the class standard Morris method of analysis in order to define on which design parameter should we concentrate, because building energy models are made of a huge amount of input data. And so the first main problem is to select which type of parameter to be used.
Yeah, thank you very much. Thank you very much. So we will continue. Thank you. The organizers announced that we are in some delay, so I would please ask the next presenters to stick to the time. Now it's my pleasure to present you Andrei Vladimir Lisiu, a building performance advisor and a building services engineering with 10 years experience in technical advocacy, research, design, installation, commissioning, and operation of technical building systems. Furthermore, Andrei Lisiu is experienced with European projects and European Commission service contracts like EPB Center or
the digital transformation of buildings. I've been very I'm sure we have a lot of synergies to explore following this event. Although my previous colleagues and speakers from the user project painted a very nice scene, backdrop regarding NZEB, regarding EPB standards, the ongoing EPBD revision, and the underpinning EU renovation wave, I would like to zoom out even further and ask ourselves, where do we stand today? Science is converging on an all-encompassing dogma, which says that organisms are algorithms and life is data processing. Intelligence is decoupling from consciousness. Non-conscious but highly intelligent algorithms may soon know us better than we know ourselves. These are some extracts from Homo Deus by Yuval Noah Harari. He wrote a nice trilogy. I really recommend all of you to have a read. Now, this is already reflected when it comes to buildings and the smartness of buildings at EU policy level. And now I slowly zoom in the content and scope of my presentation. In 2018, the amended EPBD introduced, when it comes to smartness, building automation and control systems requirements, and the so-called smart readiness indicator. On the bottom, it's actually an image. There is a link behind it. When you will get the conference follow-up package and the PDF slide deck, you can access all these links. The building automation controls systems industry has prepared a tool to implement this at national level, these requirements, and to also check compliance. So I cordially invite you to explore. And in terms of smart readiness indicator, I included two images with links behind. One is the final report of the second smart readiness indicator technical support study, which, let's say, covers all the process under spent so far, and the first version of the SRI assessment, which is a qualitative assessment. And in the middle, you see the recommendations report that was prepared by one of the topical groups that played an active role in the shaping of the SRI, which is chaired by Riva. And this one is ensuring that the SRI is future-proof, so that it can meet the constantly evolving circumstances, especially this digital transformation that's underway. Just to understand the dynamics, this is maybe my own perspective. I see the box requirements and the smart readiness indicator very similar to the eco-design and energy labeling regulations. On one hand, you have an eco-design regulation that is defining the sunset for the least efficient products. This is the so-called push, and the energy label basically raises awareness and nudges, let's say, better purchasing behaviors, and that's the pull. So in terms of EPBD, I see the same dynamic between these building automation control systems requirements and the smart readiness indicator, the push and pull. A brief overview where we are today. As I said, the SRI was introduced in 2018 and is ready and has been adopted by the European Commission since autumn last year, following two SRI technical support studies. And as I said in the previous slide, the first smart readiness indicator version, this qualitative assessment, is ready. And in parallel, the SRI legal acts, the regulations attached to this instrument within the EPBD have actually entered into force in January this year. Now it's up to member states to test the SRI at national level. And as you well know, by design, the EU's principle of subsidiarity is applicable. And furthermore, the SRI is a voluntary scheme. For those of you that are not so familiar with the SRI, I extracted here some images from the final report. On the top right, you can see the expected benefits from having an SRI, but I will focus rather on the content. There are three key functionalities and I like to name them shortly. Number 1, people, number 2, the building, and number 3, the energy systems. And if we go in a bit more detail, you can see that this assessment is taking into account the domains that you see here on the vertical, on the left-hand side of this image. And these are technical building systems or HVAC systems, but it also has the dynamic components of the envelope, electric vehicles. And here on the top, you can see the impact criteria against which these domains are scored. And this can be then further aggregated using weighting factors. And these are the weighting factors which you see here on screen that have been acknowledged for the time being by the majority of EU member states and stakeholders that have been involved in the so far shaping of the SRI. I'll end this slide by saying that in terms of presenting the output of the assessment, you can have an overarching one single score of the SRI, as you can see here. You can have separate per the 3 key functionalities, the people, the building, and the energy systems. However, you can also have a detailed view in which you can see the domains against the impacts and easily identify how the situation looks in the details. During the SRI second technical support study, there were 2 workshops organized with laypersons. And it's very worth mentioning that when they saw this detailed view, at first they were a bit like, ooh, that's a bit too much information for me. But as soon as they heard 1-2 sentences of clarification, they said, well, actually, this is more meaningful for me because I can easily see where is the most, let's say, the biggest chunk of savings or benefits that I could get if I would improve something. And with this, basically, I jump in our USERT world or USERT vision. I'll just very shortly state that USERT is supporting the evolution of energy performance assessment and certification schemes in Europe, and it has several components to do so. One of them is the set of EPB standards, another one, without any surprise, the Smart Readiness Indicator, and all of this with the main intent to make these processes as people-centered as possible, because ultimately, all these tools need to play together to help us make better decisions and in better investments. And that's why in USERT team, we strongly believe that only an evidence-based approach, so going to measured and operational performance of buildings, could make sense if we are to renovate all buildings in Europe. These are the 3 transition paths that we envision. I will let you go through them when you receive the PDF slide deck. I'll now just focus a bit on this, let's say, visual endeavor that we have in USERT, and we try to place it within the existing ecosystem. So the smartness, the SRI functionalities, in addition to the qualitative assessment of the SRI, of course, if you have more building technology, you get a better score. But actually, in practice, it delivers a lot of added value, especially if we want to make this shift from calculated building performance to measured and then to operational, and ideally as close as possible to day-to-day activities. And by preparing a recipe of SRI functionalities, we can not only get a higher SRI score, which would most likely have a positive impact on a building's value on the market, but we would actually facilitate and enable this process. And as Jaap already highlighted, this is the way to proceed. And as Jarek said in his presentation, if we are to renovate the entire building stock, we need to do it right now from the beginning. Otherwise, we might risk having lock-in effects. And this, let's say, evidence-based approach that we see would enable a building professional to act as a sort of coach, if you want, for a household, for an office building, for a building in general, because we have this already when we think about our bodies. We have a medical doctor to turn to. When we think about our bikes, scooters, automobiles, we have a mechanic to turn to. But for buildings, this is something we need to tap now. We need to tap the potential, which will highly contribute, as is already highlighted in the renovation wave strategy, to reaching our EU Green Deal goals at EU level. Before I wrap up, I'll just say that the digital transformation of buildings is something happening, whether we like it or not. So I see it as a downhill conversation. It's like water flowing downhill. The only thing we should do now is to decide the exact path that this will go. And I extracted here a quote from a recent interview done for the Build Up platform by Stein Verbeke. He was the principal investigator of the first SRI technical support study and the coordinator for the second. And I'll just read this part. The smartness of buildings should be a means to an end and not a goal in its own right. What I see myself personally from this is that transforming digitally the built environment in Europe is just a means to arrive by 2050 to a healthy, safe, efficient, flexible, decarbonized, and sustainable building stock. If you want to stay informed, I highly encourage you to follow us on social media, subscribe to the e-newsletters, very specific for user project, a bit more broad. If you want, you can register on Riva. And if you register for the e-newsletter on Riva, you'll get a free copy, a free electronic copy of the Quality Management for Buildings guidebook, which is highly relevant and linked to what I've just shared with you. And I just want to end by saying that we are not alone. UCERT is just one project out of a cluster. We are 7 ongoing projects as we speak, and 4 additional ones will start by the end of this year, or have started, some of them, and all of them are supporting the evolution of building performance assessment and certification, and including more indicators, especially indoor environmental quality, not only energy, but also power and costs, which makes it meaningful for people. And of course, for UCERT, my colleague Pablo will give more details about the UCERT value proposition in the following presentation. I'll just zoom out again before I close and ask ourselves, where are we heading? Are organisms really just algorithms? And is life really just data processing? What's more valuable, intelligence or consciousness? And what will happen to society, politics, and daily life when non-conscious but highly intelligent algorithms know us better than we know ourselves? With, let's say, buildings goggles, I would say, let's try to keep us as humans in the driver's seat. We can have an autopilot or co-pilot, these intelligent algorithms, but we are the ones behind the wheel. And we should always remember that buildings are built for people, and it's actually the people that use the energy and not the buildings themselves. Thank you very much for your attention. I'm open to answer some questions now if we still have time. Otherwise, please follow up with me via LinkedIn or my email. Thank you very much again.
Thank you very much for this very interesting presentation. Only one question. If you have any information about the different speed of implementation of this type of indicator in different parts of Europe, if there is some difference, and if you can say some words about how this program could be eventually promoted to have a better implementation in Europe. Thank you.
Yeah, thank you, Florin. That's actually a very helpful question. So I have some information, but some of which I cannot disclose as it's still something that will be communicated by the European Commission. Actually, there is a third service contract that has just started in the past 2 months. And there were 2 sessions on the SRI during the concerted action meeting and at the end of May of the EPBD concerted action meeting. And what I know from that, and I can share with the audience here, is that there are quite a few member states that have already started turning the wheels when it comes to the national testing. And us at RIVA, via the USER project and the sister projects, we are, let's say, holding our horses until this process is unfolding, and look forward to support all these endeavors at national level with all the EU level initiatives that are happening and providing insights on how to best do it. But what I can already say is that there is this different approach than from EPCs, because in EPCs it was rather a bottom-up approach. So each member state had to develop its own assessment procedures. But here we have a common assessment procedure to begin with, which of course, like the set of EPB standards, needs to be tailored to the national context, and it's only natural that it will unfold like that. So basically, this is the place we are in time, and we anticipate that in autumn these activities will start unfolding at a faster pace. Up until now, it was a bit of a waiting period, also with all these other policy instruments that are happening in parallel with the renovation wave. And we are here to support also the Romanian endeavors when it comes to the SRI national testing. So don't be a stranger. We are here. Just contact us and we will connect you to all the right knowledge base and people.
Thank you very, very much, Andrei. Thank you and good luck. And you are welcome here as usual. Okay, thank you once again.
A short comment, if possible. Instead of thanking to Andrei for his contribution to our event, let me say that Andrei is a Romanian product. You followed Polytechnica University from Timișoara, and now you are a very known representative of the Romanian school in Europe. And also, it's important to say that Andrei is one of the main engines, most involved in European projects, and a lot of information coming via LinkedIn, Facebook, Twitter, in fact, is prepared by Andrei. So thank you, Andrei, for keeping us informed and for your huge contribution. And I don't know if I'm allowed to say that you will be also a big engine, a very important engine for EPB Center. I leave to you this information if it's public or maybe not now.
Sorry, could you repeat that? I got a bit of a gap in the connection.
I said that you will be one of the main engines of EPB Center. And I don't know if I'm allowed to say the big surprise. Maybe you want to keep it for another time, or I don't know. It's up to you to say what important role you'll play in the next, in the future.
Yes, mulțumesc, Cătălin. Indeed, some changes in roles, but I will mostly be doing the same things. It's still not black on white, as we say in Romanian language, I think. So I'll keep that on social media, just be on the outlook when it's official. But thank you very much, Cătălin, and congratulations for yet another successful conference.
Mm-hmm. But thank you, Andrei, and although it is not official, be aware that you are a member of the EPBD Center team.
Yeah. Thank you. Florin?
Thank you. Now it's the time to present you Pablo Carnero Melero from Universidad Politécnica de Valencia. and he has a degree in HVAC and is an expert in building energy dynamic simulation, renewable energies, and national EPC schemes. Since 2019, is project manager at the International R&D department in the Valencia Institute of Buildings, having participating in different competitive projects at international level focused on energy efficiency and sustainability in the built environment. He is currently a PhD student in the field of energy certification schemes in collaboration with the architecture department at Universidad Politécnica de Valencia. He also collaborates with urban energy transition study groups in the field of energy poverty. Today, he will present U-cert value proposition, structure, and methodology testing. Welcome.
Hello, hello everybody. Thank you for the presentation, Karin. I'll start right away, and just want to make sure that you can hear me correctly and you see the screen fine.
Yes.
Yeah. Okay. Great. Well, thank you very much for the organizers of the event for inviting me to this conference, and congratulations for having prepared such an interesting and motivating event. Little more to add to the wonderful presentation that Florian gave. Just maybe state the email just in case you want to stay in touch afterwards. And I'll also state that I'm energy engineer by background, and I'm currently the U-cert coordinator of Work Package 4, which deals with the case study testing, a bit of which I'll be presenting right now. Yeah, so I'll present the key elements behind the U-cert structure and methodology testing. The testing process, however, is still ongoing, so I won't be able to showcase the results of such testing today. However, if you find it interesting, feel free to follow the project on social media so you can keep updated on the latest findings. A lot has been said so far, but I'll just wanted to introduce the whole topic. So why U-cert? So some of the key elements or challenges that the project is supposed to be reacting upon is the fact that many existing certification assessment schemes are not compliant with EU legislation that has been detailedly said here today. Current national and regional energy performance in buildings assessments are not comparable throughout Europe. This is something also that Jaap Hougeling raised during his presentation. Many existing energy performance certificates lack user-friendliness, reliability, and therefore credibility. And also current TPCs and EPB schemes fail often to reflect the smart dimension of buildings, which strongly falls in line with my colleagues and Andrea Lich's presentation. Very quickly, I want to place U-cert in this like matrix of the different types of EPB assessments. Just so everybody can place themselves and what to expect from the project and from my presentation today. Any EPB assessment can be classified in the following metrics, depending on whether it is based on calculations or measurements, and whether it aims at reflecting standardized or actual conditions. Right. Each type of assessment responds to a specific value proposition. So, for instance, the standardized assessment serves for comparison purposes between buildings and building designs, where the ones reflecting actual conditions follow more of an energy audit-like approach, for instance, we could say. So at the top left, based on standardized calculations, there's the U-cert asset assessment. It's been defined based on the choices made on the overarching EPB standards. And this type of assessment would result in an EU harmonized and standardized comparative assessment. Moving downwards, we would find the tailored assessment, which it is based on calculations and they're tailored, for instance, actual conditions, and could be understood as a digital twin of some sort. And it is, however, out of the scope of the project, but it's very well connected with previous presentations, I believe. At the bottom right, so actual assessment based on measurements, there's the U-cert as measured assessment. So it aims at reflecting the actual performance of the building, relying on existing measurements covering energy, cost, and indoor environmental quality indicators. And this assessment, is key in the evolution of EPB assessments, since it relates to information relevant for the user and deeply connected to the user's behavior and building operational, such as, for instance, the energy invoices. They would be sort of as measured assessment. And moving upwards, we will find the user operational rating, which is a normalization of the as measured assessment on energy. In the scope of user, this assessment covers energy indicators for heating, and also leverages the smart readiness indicator previously presented by my colleague, Andre Litiu. USERT, being a coordination and support action, so a CSA type of project, is not directly going to develop a proprietary simulation software, but rather is going to scale up pre-existing tools from other innovation initiatives to test its inclusion to the next generation EPB assessments. Collaboration agreements have been or are pending to be signed with relevant projects. However, as Jaap Hagelin presented, it is an ambition of USERT, and I believe also of EPB Center, to lay the foundation for further development of a calculation kernel relying on the EPB standards that could be widely uptaken by member states. Very brief presentation. So the user value proposition will be tested relying on 16 different pilot buildings from various typologies and covering a total of 11 countries. Each of these pilot buildings has an energy performance certificate issued according to each national or regional methodology, which will serve as benchmark for the testing phase. A bit more on the user asset assessment. So with a view to assessing how in line with the user asset assessment is each of the regional and national methodologies for issuing energy performance certificates, the user comparison and calculation toolkit for national annexes will be developed, relying on the work carried out by EPB Center on the numerous supporting spreadsheets available at EPB Center's website. This tool will be developed in WordPax 5, so still work in progress, and will serve to help member states to see the impact of some of the national choices made under national methodologies, and then provide guidance in filling in or improving their national annexes. So apart from the use of the user comparison and calculation toolkit for national annexes, there will be other digital tools to be developed. And the most relevant in terms of added value to the current EPB schemes is the building operational rating solution, and that is the core of the user case study testing. This tools will be built on the methodologies behind the user as measured assessment and the user operational assessment. As exposed before, the user as measured assessment will cover indoor environmental quality, cost, and energy indicators. I'll start with a brief presentation on the as measured indoor environmental quality indicators in the user case studies. So in order to assess this, it'll be needed to rely on existing monitoring or to perform dedicated monitoring campaigns. To ease and harmonize each case study data collection, the Aldrin tail spreadsheet will be used. I'll give a bit more information later on, but this was a tool developed in the H2020 Aldrin project, which was already finished, and some of the added value is going to be leveraged here in USERT. And for the residential buildings with lack of measured data, the use of the EEE Reno non-expert online tool will be used. And the idea behind this dual testing phase is to not leave out of the scope of the indoor environmental quality assessment existing buildings lacking dedicated indoor environmental quality monitoring. Very often, existing buildings, as I'm sure you're all aware of, existing buildings without measurements are the ones in the greatest need of intervention, and the ones which can benefit the most from even qualitative assessments or low-level assessments. Right? We shouldn't stop, providing a renovation roadmap to buildings which may lack detailed monitoring just because they don't have that quality of data. For the evaluation of the as measured energy indicators, several sources of information can be used, such as energy invoices, metro readings, building management systems, etc. And such information will serve as inputs for the general questionnaire that will be disseminated with the case studies. I'll speak a bit on this general questionnaire and the whole concept behind it and to what purpose it serves. For the evaluation of the as measured cost indicators, the main source of information to be leveraged are the energy invoices, which will be inputs to the general questionnaire as well. As I was saying, the idea behind the general questionnaire is to set the basis of a common data repository that can account for the different information that should be fed to this set of digital tools developed in Work Package 5. Moving on to the user operational assessment. Sorry, it's not working. Yeah, here. The operational energy indicators will be calculated by relying on measured data covering the heating energy consumption. And for this purpose, the Sensei EN 15378-3 spreadsheet will be used. The user operational assessment will only cover heating use for now, since there's only one EPB standard dealing with measured energy performance in buildings so far available, and it is limited to the heating service. However, such as in the same line as the ambition of developing a calculation kernel for the whole set of EPB standards, there is also the need to push forward the measured energy performance in buildings by the maybe development of additional EPB standards that can cover all the building uses and not only the heating service. That is also one of the ambitions of the project, although it will not be possible to develop it within the project. But however, we aim at laying the foundation for further initiatives and innovation developments. And for the use of the smart readiness indicator, the source of information will be case study holders' own knowledge of the building or a dedicated visit to it, as it is a qualitative assessment, as my colleague Andre already presented. And the tools to be leveraged will be the method A and method B supporting spreadsheets for the latest available methodology for the smart readiness indicator. And yeah, lastly, the general questionnaire will also need to implement general information from the building. And for that, existing EPCs or assessment reports from the pilot buildings may be used as valuable sources of information. This case study testing phase should provide additional indicators and bring added value to the user's value proposition as next generation EPCs, with view of becoming more reliable and meaningful to the users. Just I have a couple slides on the tools to be used, just in case anybody who was not aware of them can look them up further and maybe gain a better understanding of what they are. I'll briefly start with the Aldrin tail, which covers the indoor environmental quality indicators within the as measured assessment of user. This tool was developed, as I said, by the H2020 Aldrin project, which already finished, but the website is available for anybody who wants to maybe take a look at the deliverables and the methodology developments. But this is an assessment which provides an index for health and well-being, covering a subset of categories like temperature, acoustics, indoor air quality, and lighting. And we feel that this was a very added value to current EPC schemes, which at least for the partner countries that we have in USERT, we have identified that almost none of them cover indoor environmental quality to any extent. Some of them do deal with the ventilation data, but the implementation of a detailed assessment is not yet in place in most of the countries. We also have the Jubilee Arena combined performance label, which was this qualitative assessment for residential buildings who may lack the monitoring, the needed monitoring. And it's just it's already a web-based tool who is finalizing the process as the Jubilee Arena project comes to an end. But it covers different indicators and guides the user, the building occupant, with very qualitative images that they can identify and self-assess the status of the indoor environmental quality in their building, although they may not have measurements. The Sensei tool, the spreadsheet based on the EN 15378-3, it covers two different methods to provide what we call the operational energy rating for the heating service. And it is a spreadsheet that you can use either the seasonal data interpolation method or the energy signature method, fully relying on the EPB standard, and in the end can provide the delivered energy for heating already normalized. So this indicator could be used to compare how different buildings do the heating service, because it's already normalized based on weather conditions and equipment behavior. So, you know, it is possible to obtain a comparative indicator based on measurements, also based on calculations, as we all are aware. But this operational assessment would be in that line. Very briefly, we're also obviously leveraging the smart readiness indicator, which I won't present, since already Andre gave a very good explanation on it. I won't get into details, but I reckon it is a valuable assessment complementary to existing EPC schemes, because, for instance, can trigger building electrification and digitalization, which constitutes a must for the needed building decarbonization, as already my colleague Andre mentioned. Yeah, I won't get into the details of it. So the output data, different impact and domain scores covering the whole aspects of the building. And if I may, I just want to take this last 30 seconds to present a bit of the work in progress that we have in terms of the of an EPC label, right? This is another key finding of USERT as a result of the ethnographic research performed in the different countries, was that the design and layout of the EPCs need to become more user-friendly. And this is why USERT has developed a tentative structure, again, still work in progress, of an EPC report showcasing different information depending on the type of user interacting with it. This should evolve to a fully digital version, but does not make sense to provide the same information to an expert user fully aware of what primary non-renewable energy is than to a building owner who may know very little about energy and energy performance. So again, this is still work in progress, but the main idea is to provide all the relevant information to the expert user and only a reduced subset to the non-expert, adapting the language and focusing on down-to-earth information with a view of appealing to his or her knowledge, and try to boost building renovation in a successful way. So yeah, more information in terms of energy needs, building characteristics, also technical building installations, and the whole logic is to give a subset of information to the non-expert user and to give the whole information to the expert user. Obviously, this is very in line with digital logbooks and building passports. So the initiative in USERT in this line is to provide evidence of a more user-friendly design. As I said, and I'm almost finished with the presentation, we're currently on the case study testing phase, but the compared analysis is coming in a few months. So I would encourage you to to stay tuned to the project, because as soon as we make progresses, we will be disseminating them accordingly, and probably this is something relevant to other initiatives and other endeavors that you may be having in your either professional life or your policy developments and that kind of thing. So this is it for my side. I'm happy to take any questions, and thank you very much for your attention. And again, congratulations for such a successful and meaningful event.
Thank you very much also. And I know that this is, as you said, a work in progress, an ongoing process. But if you can say what, in your opinion, will be the very important steps to be done in order to extend this methodology and eventually for the implementation.
Well, I mean, I think that I fully agree with what I think Jaap Hogeling said before, that and also in connection with what Andre mentioned, that maybe the difference between the smart readiness indicator, for instance, and common EPCs is the different approach, right? Each country developed its own calculation, and then we found with the problem that they were very different, and different ambitions, different labeling schemes, even. So they could not be compared throughout Europe. So I think that one breakthrough could be to develop this calculation kernel fully based on the EPB standards, so we can make them comparable between the countries. This should be something like a flagship initiative of this, and then maybe to include other elements that we have realized now after the experiences with the EPC schemes, that they appeal more to the user. I'm speaking about, not only the smart readiness indicator, but also in the environmental quality and maybe renovation roadmaps, and obviously adapting the language to different types of user, because it makes no sense to speak the same language to somebody who is fully aware of what energy performance is than to somebody who is knows very little and maybe is not even aware about how much energy is consuming or how much money is paying on the energy invoices. So very ambitious, but I think that we're on the right track. Yeah.
Thank you very much, and good luck. We will conclude now the first session of today, and I invite you to be back on 14 hour when we will start the second part of the conference. Thank you once again for your participation, and we are welcoming you in the foregoing process. Thank you.
Doar să spun și română că ne întoarcem la ora 2 fix. Toată întârzierea va fi preluată în pauză, de către pauză, și prin urmare vom reveni cu celelalte 2 sesiuni la ora 14. Vă mulțumim frumos și vă așteptăm înapoi la ora 14.
Lumea, așa cum o cunoaștem în acest moment, nu ar putea exista fără standarde. Acestea permit funcționarea tuturor lucrurilor din jurul nostru, asigură confortul, siguranța și securitatea fiecărui aspect al vieții noastre. Standardele au devenit din ce în ce mai necesare pentru a garanta calitatea produselor și serviciilor în cele mai diverse domenii: energie, transport, construcții, inovare, turism, medicină și multe altele. Standardele permit intrarea pe piața noilor soluții și sunt un aliat puternic al noilor tehnologii. Ele oferă un limbaj comun pentru dezvoltarea afacerilor de succes. Standardele ne simplifică viața, oferindu-ne încredere și noi așteptări.